Hello friends, welcome back. In this video we will discuss how VxLAN EVPN interacts with VPC for dual attached endpoints that are connected to a pair of VPC switches. Like we discussed in the previous videos, NVE source interface is the default BGP next hop for advertised routes. So if we try to understand this using our previous topology, spine 1 and spine 2, and then we also have 3 leaf switches where leaf 1A and leaf 1B are in a VPC pair. So let's assume client VLAN 20-1 has just rebooted. It has sent any sort of traffic towards its default gateway, which will be configured on the leaf switches using Anycast gateway, which we will discuss in a few minutes. So the traffic gets to either leaf 1A or leaf 1B, and as these leaves are in a VPC pair, their ARP entries will be synchronized. So both leaf 1A and leaf 1B will advertise this MAC and IP information towards its upstream spine switches, which are also route reflectors. And as these are route reflectors, they will reflect or advertise these updates towards leaf 3, which is acting as a route reflector client. And when these leaf switches advertise this route type 2 towards the spine, the next hop address they will use is their loopback 0 interface, which is 1.1.1.11 and 1.1.1.12 for leaf 1A and leaf 1B respectively. So this is exactly what we mean when we say the NVE source interface, i.e. loopback 0, is the default BGP next hop for advertised routes. So the route type 2 and route type 5 that we advertised from leaf 1A and leaf 1B towards the spines will use loopback 0 on these leaf switches as the BGP next hop address. Like we discussed, in a VPC environment, both VPC peers will advertise the duplicate EVPN MAC and IP route, i.e. route type 2 and 5 towards the spine switches, i.e. the route reflectors. Now the remote leaf switch, which is leaf 3 in our example, will receive an update from leaf 1A and also an update from leaf 1B for the same prefix, i.e. for client VLAN 20-1. With all attributes being equal, it will prefer leaf 1A as the BGP next hop value because leaf 1A has a lower router ID, which is 1.1.1.11 in our topology. What this means is that leaf 3 will always prefer leaf 1A for any BGP advertisements that it receives from the VPC pair, which is leaf 1A and leaf 1B. So if we think about it from a traffic flow perspective, if client VLAN 20-1 needs to send any traffic towards client VLAN 20-2, and it sends the traffic towards its upstream LAN switch, which is LAN switch 1 in our example, and from LAN switch 1's perspective, the uplinks are configured in a port channel, so the traffic can get hashed either towards leaf 1A or leaf 1B. So there will be load balancing when traffic egresses towards the VxLAN fabric. However, for the return traffic from leaf 3, it would always prefer leaf 1A as the BGP next hop because of its lower router ID. So this is how traffic will be polarized for any return traffic. So like we discussed, the end result being that the egress traffic from the dual attached VPC member is load balanced as expected. However, the return traffic is always polarized based on the BGP best path selection criteria. And that's exactly the problem that we're trying to solve. So let's talk about the solution next. So To solve this problem, we use VPC Anycast VTEP. So more specifically, this is a secondary IP that we configure on loopback 0 in our example, which is also the NVE source interface. So the VPC peers will share this duplicate IP address on the NVE source interface, which is loopback 0 in our topology. So leaf 1A has 1.1.1.1 as the primary IP under loopback 0, and leaf 1B has the IP address of 1.1.1.12 under loopback 0. However, they will have a shared duplicate IP address of 1.1.1.100 secondary under the loopback 0 interface. And this will be configured on both leaf 1A and leaf 1B. So as discussed, peer 1 has an IP address of 1.1.1.11/32. Peer 2, i.e. leaf 1B, has an IP address of 1.1.1.12/32. And both of these peers will have the duplicate shared IP address of 1.1.1.100/32 secondary configured under the loopback 0 interface. So let's say if we check the configuration of interface loopback 0 on leaf 1A, we see that we've got the IP address of 1.1.1.11/32, and we also have the secondary IP, which is 100.1.1.1/32. And now if we check the configuration of loopback 0 on leaf 1B, we see that the loopback IP address is 1.1.1.12/32, and we also have the same secondary IP of 100.1.1.1/32. So if we send some traffic from client VLAN 20-1, so first of all, let's ping the default gateway, which is 192.168.20.254 on VLAN 20. So this IP of 192.168.20.254 is the Anycast gateway IP that we have configured on leaf 1A and leaf 1B for VLAN 20. So if we do a show run interface VLAN 20, we've got the IP address of 192.168.20.254, and this is running in mode Anycast gateway, and we have the same IP configured on leaf 1B as well. So if we do a show run interface VLAN 20, yeah, we've got exactly the same IP configured, and it's running in fabric forwarding mode Anycast gateway. So as discussed previously, leaf 1A and leaf 1B are in a VPC pair, and we are using port channel 999 as the peer link, and then management interface 0 as the peer keep alive. So that part has been pre-configured. So if you are not clear about how VPC works, I would suggest you to check out my video about VPC in my channel. So leaf 1A and leaf 1B should now have an entry for client VLAN 20-1 in its BGP table. First of all, it will create an ARP entry for client VLAN 20-1 under VRF tenant 1. So we do have that entry here, like we see 192.168.20.10 with this MAC address in VLAN 20, and likewise we should have the same entry created on leaf 1B. So now let's check the BGP L2 VPN EVPN table on leaf 1A. So we need to do show BGP L2 VPN EVPN to check the BGP table. So it has a type 2 entry for 192.168.20.10, and this is the interesting part, which we now say that the next hop value is 100.1.1.1, which is the secondary IP under loopback 0 on leaf 1A. And if we check the same entry on leaf 1B as well, so it has the same MAC and IP root type entry. So that's root type 2 with a MAC address of this value that we see on the screen and an IP address of 192.168.20.10. And the interesting part being the next hop is 100.1.1.1, which again is the secondary IP that we configured under loopback 0 on both leaf 1A and leaf 1B. So now if we go to leaf 3 and check its BGP table for root type 2, so we see that it has an entry for 192.168.20.10 with the MAC address of client VLAN 20-1 and the next hop being 100.1.1.1, which is the secondary IP under loopback 0 of both leaf 1A and leaf 1B. So if leaf 3 needs to send any traffic towards client VLAN 20-1, it will send the traffic to 100.1.1.1 encapsulated in VxLAN header. And if we check the route for 100.1.1.1 on leaf 3, we see that it will get load balanced towards spine 1 and spine 2 on ETH 1/1 and ETH 1/2 respectively. So if we just confirm the devices attached on leaf 3 under interface ETH 1/1 and ETH 1/2, we see that we are connected to spine 1 and spine 2 on those interfaces. To confirm data forwarding, if we try and ping from client VLAN 20-2 towards client VLAN 20-1, so let's verify that, but before that let's check the IP interface configuration on client VLAN 20-2. So we see that we have an IP of 192.168.20.20. So let's try and ping 192.168.20.10, which is the IP address for client VLAN 20-1. So yeah, we can ping it all day long. Like we see, the pings are reachable, and like we discussed previously, this solution where we are using the shared loopback secondary IP on both the VPC peers to advertise the BGP updates is called VPC Anycast VTEP. So with VPC Anycast VTEP, the VPC peers share a duplicate IP address on the NVE source interface, and precisely speaking, it's the secondary IP on the loopback 0 interface, which is used as the NVE source interface. So friends, this is how VPC interacts with VxLAN BGP EVPN in a multi-homed or in a dual-homed environment where endpoints are connected to a pair of devices running in a VPC setup. I hope you liked the content of this video, and if you did, please give it a thumbs up, share with your friends and colleagues, and if you are new to this channel, please subscribe to this channel. And if you found this content helpful, please consider supporting us via Buy Me a Coffee. The link is in the description. So friends, that's it for this video. I will see you with more such contents in the upcoming videos. So until then, take care. Bye bye.